So today we'll discuss about gas laws, the laws of gas. Whenever we say gas law, we mean perfect gases. So what is a perfect or ideal gas? Is one which obeys the gas laws under all conditions of temperature and pressures. Those gases are called perfect or ideal gas. But the thing is that generally there is no such gas which obeys the gas laws under all conditions, but for our convenience we assume some gases like air as a perfect gas or ideal gas that obeys the gas laws. So let's discuss what are the gas laws available for us from engineering, thermal engineering point of view or thermodynamics point of view. You have already know some of these laws. Say that means a substance may be in liquid, solid or gaseous form, but if it comes from liquid to gaseous form, then then the vaporization is complete. No liquid is suspended in the vapors, then that is called a gas. For example, say nitrogen. Nitrogen may exist in liquid form also, but generally at atmospheric pressure and temperature this is found in gaseous form. Oxygen also same. At high pressure it may be in liquid form. And atmosphere is of course we found in gaseous form, that means vaporized form. Now Boyles law. What is Boyles law? The Boyles law, all gas laws are concerned with three things, three properties of the system: pressure, temperature and volume. For gas laws we assume that the temperature remain constant. Under that condition, the condition of a Boyles law is temperature remain constant. If that is so, volume of a perfect gas varies inversely as the absolute pressure. Remember here both pressure and temperature are considered in absolute form. Temperature is constant, so we need not express temperature in absolute scale, but pressure should be absolute. You have already know what is absolute pressure, what is gauge pressure, what is vacuum pressure. So the pressure should be in absolute scale. So the law is what? Volume changes inversely with absolute pressure. That means if the pressure increases, volume decreases. If the pressure decreases, volume increases. And mathematically that is expressed like this: volume is inversely proportional to P, or you can say volume is proportional to 1 upon P. 1 upon P thaka karne hame ki kam volume varies inversely as the pressure, and the condition is temperature should be constant. And the same thing can be expressed this way, that means PV remain constant. P multiplied by V remain constant. This is the law. So if that is so, that means for any combination of pressure and volume, it will remain constant. In some cases pressure will be more, volume will be less, and in other cases pressure will be less, volume will be more, but the PV will remain constant. Say in a PV diagram, say this is a PV diagram. X-axis is V, volume, and Y-axis is P, pressure. Suppose the state of a gas changes from state 1 to state 2, and at state 1 the pressure is P1 and volume is V1, and at state 2 it changes to P2 and V2 respectively. So the law says that P1 V1 is equal to P2 V2, this one, and P3 V3, any combination, it always remain constant. Pressure multiplied by volume remain constant. So that is Boyles law. So Boyles law, the condition is temperature remain constant. Under that condition This is the law. Then another law, that is Joules law. These laws are named after the name of some scientist who discovered this law. So what is Joules law? For Joules law, absolute pressure remain constant. If that is the condition for Joules law is absolute pressure remain constant. In that case, volume changes. How? How does the volume change? The volume of a perfect gas varies directly. In Boyles law, it was inversely. It is directly. That means if temperature increases, volume will increase. If temperature decreases, volume will decrease. From our day-to-day life experience also, we can say that with temperature, volume increases. With decrease in temperature, volume decreases. So that is the law, Joules law. So mathematical form is V is directly proportional to T. T is the absolute temperature, V is the volume. Condition is P remain constant. Then we can write V upon T is constant. So same, V1 by T1 is equal to V2 by T2 equal to V3 by T3. This way we can write the Joules law in a mathematical form. So for any system, if it is given that the pressure remain constant, then we can apply this Joules law. And for any thermodynamic system, if it is given in the problem or in a situation, it is given that the temperature remain constant, then we can apply Boyles law. But we can also say the Joules law can also be stated like this. If V remain constant, then P is directly proportional to temperature. If temperature increases, pressure increases directly. That means P1 by T1 equal to P2 by T2. So Joules law can be stated for a constant temperature as well as constant pressure as well as for constant volume. If volume is constant, the relation is with a relation of P with T. If pressure is constant, then relation of V with T. That is the law. And based on these two laws, we can combine both the laws, Boyles law and Joules law we can combine. So what is Boyles law? Volume varies inversely with pressure. And what is Joules law? Volume varies directly with temperature. Now if we combine these two laws for generalization, then we can say volume varies directly with T upon P. We will not say directly or inversely or directly, but we will say directly only. Volume varies directly with T upon P, combining both Boyles and Joules law. So also we can say PV is directly proportional to T. And so PV upon T is equal to constant. That is another form of combined Boyles and Joules law. PV by T is equal to constant. So for different state 1, state 2, state 3, like this, you can say P1 V1 by T1 equal to P2 V2 by T2 equal to so on, remain constant. So Boyles and Joules law combined, jodi ami koro, there will be three properties associated, that is pressure, volume and temperature. For Boyles law, it is volume and pressure, temperature remain constant. For Joules law, it is volume and temperature, pressure remain constant. Now, Joules law. There is another very important law in thermodynamics, that is the Joules law. So this law says that the change in internal energy, change in internal energy DUD represent goes to DU. Of what? For any gas law, it should be perfect gas. You always write, you don't say simply that this. You have to mention for a perfect gas. Sometimes we may not mention as a perfect gas, but we mean that these gas laws are only for perfect gas or ideal gas. So the change in internal energy dU of a perfect gas is directly proportional to change of temperature dt. So in the previous two laws, whether it is Boyles Law, Joules Law, or combined Boyles-Joules Law, that was directly we are talking about pressure, volume and temperature. But in this case we are not talking about simply internal energy, but we are talking about change in internal energy and change in temperature. That means change in internal energy is directly proportional to change of temperature. So mathematically you can write du is directly proportional to dt. This stands for change. And mc, du is equal to mc into dt. This mc is a constant. That means this proportionality constant are combination of m and c, where m is the mass of the gas. Say we are considering a system, that means the system will have a particular mass, and that mass we have to consider. du is equal to mc. What is c? dt we already know, this is change in temperature, du is change in internal energy, and c is specific heat. Now what is specific heat? Anybody can tell what is specific heat? Okay, so specific heat is amount of heat required to change the temperature of one body by 1 degree centigrade or 1 degree Kelvin. That is called specific heat. So where m is the mass of the gas, c is the constant called specific heat of a gas. So what is specific heat c? Again we can let us repeat. C is amount of heat required to increase the temperature of 1 kg of a gas. Suppose air temperature is at present, say it is 35 degrees centigrade. We take some air mass 1 kg and its temperature is 35 degrees. Now we want to add some heat to this mass, and what will be the amount of heat required to increase it to the 36 degrees centigrade? The amount of heat required will be called specific heat. Okay, per unit mass, per unit increase in temperature, that is called specific. Specific means for 1 kg mass, for 1 degree centigrade, that is called specific heat. So this equation we also can write U2 minus U1, that means change in internal energy, equal to mc T2 minus T1. That means what? For a say gas from temperature T1 to T2, if it is increased from T1 to T2, then that will be this. 1 is the initial state, 2 is the final state. So change in temperature is T2 minus T1. So internal energy will increase. If the change in temperature is from say higher temperature to lower temperature, say this here is temperature 1 to 2, if the temperature decreases, then T2 minus T1 will be negative. So negative indicates, I got at a negative sign pump, that indicates that the internal energy U2 minus U1 is also negative. That means the internal energy decreases. So Joules law says that internal energy increases with increase in temperature and decreases with decrease in temperature. And this is a very important relation for our next chapters or classes. So This is required in all the semesters. This semester's 5th semester and also for 5th and 6th semester. Now, gas equation. We have already discussed Boyles Law, Joules Law, Boyles Law and Joules Law combination, and also Joules Law. Now, considering the general Boyles Law, Joules Law combination, if we consider the mass is 1 kg, then the gas law is PV upon T is equal to R. This R is a constant, and this R is called the characteristic gas constant. Then this term is very important. R is called characteristic gas constant. So what does this word means, characteristic? That means it says about the character of a gas. That means the value of R is different for different gas. For air it is different, for nitrogen it will be different, for oxygen it is different. That means from the value of R we can say what the gas is, or from opposite side we can say if the gases are different, then the value of R will also be different. So in place of 1 kg, if we put m kg, then the equation will be like this: PV by T equal to mR. Or we can write PV equal to mRT. This is the most popular equation in thermodynamics. You have already studied this PV equal to mRT in chemistry, first semester or second semester, also in the school level also. So PV is equal to mRT. So what is P? Absolute pressure. What is V? Volume. M is the mass of the gas. R is the constant called characteristic gas constant, and T is absolute temperature. And accordingly, this equation is called characteristic gas equation. Now the question is unit of R. What will be the unit of R? So from this equation, R is equal to what? P V divided by MT. If we put the units, pressure equal to, what is pressure? Newton per meter square, unit of pressure, into volume is meter cube, divided by M. M যদি তলত থাকে আমি তলত লিখিব লাগিব, M is kg, and temperature তলত আছে Kelvin. So কি থাকিব গৈ? Newton meter per kg per Kelvin. Now what is Newton meter? This is Joule per kg per Kelvin. So unit of R, characteristic gas constant, is Joule per kg per Kelvin. We can also say in kilojoule. Then it will be kilojoule per kg per Kelvin. And the value of R for air is, you need to remember, in many cases you have to remember these values. Value of R is 287 kilojoule per kg per Kelvin. And if you consider in kilojoule, then it will be 0.287 kilojoule per kg per Kelvin. Value of characteristic gas constant. We have already discussed that the value of R depends on the gas. The value of R is different for different gas. And if we multiply R with M, where M is the molecular mass, then oxygen molecular mass 32, like this. From the atomic structure we can know or remember also the molecular mass. Then R multiplied by M is given as Ru, and this Ru is called the universal gas constant. What is Ru? Universal gas constant. Now why this name is universal gas constant? Because the value of Ru is same for any gas. Whatever be the gas, the value will be same.
8.14. 8.14.
8 point মই তোমালোকৰটো লৈছো 8.314 314 কি আছিল joule per mole তাৰমানে per molecule per Kelvin. This is the value for universal gas constant 8.314 and something aru kiba kibi ase but amar karone monot rakhibole hekhini sufficient value of RU universal gas constant. So kiba ta gasor jodi ami molecular mass janu characteristic gas constant ero na lage oxygen or jodi ami janu oxygen or molecular mass 32. So R into M is equal to RU. R value kiman hobo R is equal to RU divided by M. Gotike RU is equal to 8.314 divided by kiman M is 32. So that will be the value of R. Suppose air or kotha ami consider korisu. For air R equal to kiman pala monot ase ne 7 kiman asile kiman asile value 287
sir
287 ki unit ki joule per kg per Kelvin tamane m kg to whole mass tamane per kg k to whole atmosphere. So air or PV is equal to mRT. A particular mass of air, say at all air ase air pressure dhora 50 Newton per meter square ase air kini and volume is 1 meter cube and temperature is say 47 degree centigrade. Now yet mass kiman ase eta keneke kom pam ami what is the mass yet air kiman ase baki khini dia ase. So ami equation to use kori kobo paru equation to pa ami ki pam m equal to what PV divided by RT. So P kiman dia ase 50 Newton per meter square. Volume kiman dia ase 1 meter cube. So meters Newton etu moi pisot likhim baru unit tur karone ami unit tu nelikhile tomaloke just janile whole unit tu no ki hoy just a minute. Now tolot ke likhim ami R kiman 287 joule per kg per Kelvin multiplied by temperature kiman likhim kiman likhim temperature
47 plus 270
good jog korile kiman hobo ami etu moi joa kali class ot koisilu it should be in absolute temperature 11 12 2 1 320 huh? So this is 320. So ei mass or unit to ki hobo koason etia কেজি হবো ইয়াত এইটো বিলাকত সব কেজি আছে নহয় আর হয় না নহয় তুমি সোয়া 52 হোল নিউটন পার মিটার স্কয়ার ইনটু ভলিউম মিটার কিউব ডিভাইডেড বাই কি আসলে জুল পার কেজি পার কেলভিন তার মানে উপরত যাব কেজি আর কেলভিন তো উপরত যাব আর কি থাকিল টেম্পারেচার তো temperature kiman Kelvin. So Kelvin cancel gol joule etu ki hobo meter square aru etu goi pele newton meter mane joule hoy na hoy newton meter mane joule so joule cancel thakibo thakil ki kg that is why it will be always in kg. So etu korile tumi jitu value paba that is the mass of the air for this condition. Under what condition? Air at 50 Newton per meter square occupying a volume of 1 meter cube at 47 degree centigrade. Okay, yate alop এয়াৰ আছে আৰু এটা পিষ্টন আছে ইয়াতে হ'ব এতিয়াতো গম পাইছে ইয়াত এয়াৰে আছে আৰু এই কণ্ডিশ্যনত এইটো ধৰা পজিশ্যন 1 আৰু অলপ পিছত ইয়াক তললৈ লৈ অহা হৈছে এই পজিশ্যনলৈ 2 পজিশ্যনলৈ তাৰমানে পিষ্টনটো তললৈ আহিলে সো ফাৰ্ষ্ট 1ত থাকোঁতে ধৰি লোৱা প্ৰেছাৰ at point 1 pressure is equal to say 500 Newton per meter square and volume equal to 0.2 meters cube. Temperature is equal to say 67 degrees centigrade. Eto condition ase. Now আমি যেতিয়া পিষ্টনটো তললৈ লৈ আহিলো কন্ডিশন 2 হৈ গল স্টেট 2 হল তেতিয়া ধৰা কি হ'ব প্ৰেসাৰ ধৰা কমি পেলাই হৈ গল 100 নিউটন পাৰ মিটাৰ স্কয়াৰ আৰু ভলিউমটো আমি না জানো সা ভলিউমটো আমি উলিয়াব লাগে আৰু টেম্পারেচাৰ গৈ পেলাই হৈ গল 27 ডিগ্ৰী সেন্টিগ্ৰেড সো দিস ইজ দ্য কন্ডিশন प्रथम कन्डिशनत एयर खिनिर प्रेसार दिया आछे वॉल्यूम दिया आछे टेम्पारेचार दिया आछे सेकेंड कन्डिशनत प्रेसार आछे टेम्पारेचार आछे वॉल्यूम आनि ना जानो एई वॉल्यूमটো আমি উলিয়াব লাগে তো কেনেকৈ উলিয়াম সিম্পল আমি গ্যাস ইউনিভার্সাল গ্যাস ল ইউজ কৰিম P1 V1 by T1 is equal to P2 V2 by T2 ইয়াত আমাক মাস কিমান আছে দৰকারই নাই আছে নে দৰকাৰ So from this equation we can find the value of V2. I mean, কি উলিয়াব লাগে V2. এবিলাক সব value put কৰি দিয়া. So 1 means a P1 V1 T1 লিখিম. So ইয়াতে value খিনি put কৰিলে কি হ'ব P1 equal to 500 into sorry V1 equal to কিমান আছিল 0.2 divided by temperature T1 kiman 67 plus 273 ki hobo 0 7 6 13 14 340 ঠিক আছে না মোৰ ক্যালকুলেশন 340 so this is equal to what P2 kiman paisalo 100 multiplied by V2 to ami na jano that we have to find out and temperature 27 means 300 so etut ami tumalake dunia ke uliaboi pariba etu cancel ei gol so what is V2 kiman hobo 5 into 0.2 into 300 divided by 340 kora jodi tumalake uliabo pariba how much volume ami ki hot pam meter cube hot pam So that is the volume. So this type of problem we have to solve frequently. This is not exactly the whole problem, but this type of calculation will be the part of the whole problem. Amar problem eta solve koribolo eneka horu calculation major thakibo. So be sure that make sure that you can solve this type of problem very quickly. Hobo thakibo. So piston remains same. प्रथम अवस्थात प्रेसार आसिल धरा 5 किलो न्यूटन पर मीटर स्क्वायर वॉल्यूम आसिले 0.1 मीटर क्यूब टेम्परेचर आसिले 27 डिग्री सेंटीग्रेड কিছু সময় পিছত ইয়াৰ প্ৰেসাৰ কিমান হ'ব যদি ভলিউম কনস্ট্যান্ট থাকে and temperature increases to 127 degree centigrade বুজি পাইছানে প্ৰবলেমটো there is some mass of air initially the pressure was 5 kilonewton per meter square volume remain constant আমি volume change হ'ব দিয়া নাই মানে piston to তললৈ যোৱা নাই ওপৰলৈ যোৱা নাই that means what piston remain in the same condition that means there is no change in volume and temperature was this much but under some condition, under some circumstances, the temperature increases. Kiman increase hol 127 degree like temperature increase hol. Hetu khetrot pressure kiman hobo. So etu koriboloi etu ki law porise. Yat ki constant ase? Volume constant ase. So volume constant thakile you can use actually Joules law. Joules law second part of ami pressure and temperature paisilo. Hetu law apply koribo paro. But we need not use directly. You can use simple etu law use koribo parim. Q1 equal to P2 V2 by T2. This is the law. A law to kami to volume constant as the law is P1 by T1 is equal to P2 by T2. This is Joules law actually. Joules law second part to G2 paisilo. That means V1 equal to V2 volume constant ase. So from this what is P2 we can find out P2 equal to T2 divided by T1 multiplied by P1. So what is T2?
127.
T2 kiman? Temperature kiman barise 127 degree centigrade. Kelvinot kiman hobo? 400. Aru temperature T1 kiman? 300. Pressure kiman asile P1? 5 kilonewton per meter square asile. So eto change hoi pelai. Then you can find 20 divided by 3. Jitu poa hetu likhiba kilonewton per meter square. So just tumali bhabibo lage je pressure, temperature and volume ekita bostu ketia change hoise keneke change hoise aru ketia ba ami PV equal to MRT এই ইকুয়েশনটো ইউজ কৰি এই গেটাৰ হয়তো কোনবাটো M দিয়া আছে R দিয়া আছে T দিয়া নাই হয়তো P আৰু V দিয়া আছে then you can find out temperature এয়াৰৰ কাৰণে আমি উলিয়াব লাগা হয় প্ৰায় কেতিয়াবা মাছ দিয়া না থাকে মাছটো উলিয়াব লাগে so this way we can solve problems on thermodynamics by using characteristic gas equation as well as universal gas equation and sometimes by using Boyles law and sometimes by using Joules law. So Boyles law, Joules law particularly used konokorilo ko hoy. This is the general law nisina hol characteristic gas equation. Iare jeniba volume jodi eke thake that is different law. Pressure jodi constant rakha that will be Joules law again. Or temperature constant rakhile that will be Boyles law again. So etu law pra ami baki keta law loke jabo paro. So with this I complete to this class, and if you have some question, quick question, you can ask. Otherwise I will finish.